Welcome to this session. My name is Dimitris Osidis and I'm at Audacity. Today I'm going to speak about the project deploying a sentiment analysis model using AWS SageMaker. This is for the machine learning with AWS program. So I'm going to share my screen right now and the repository of the project, and we're going to dive inside it. So here is creating a sentiment analysis web app using PyTorch, which is the machine learning framework, and the SageMaker, the AWS service. Okay, this project has 7 steps. The first step is to download and retrieve the data. The second is process and prepare the data, pre-process the data. And the third one, you have the data already ready for you, and you can upload them to the an S3 bucket. Okay, so you have there the data, and with this data, you can train a chosen model in the 4th step. In the 5th step, you are testing the model. In the 6th step, you are deploying the model. Okay, and at the end, in the 7th step, you are use the deployed model inside an application, inside an app. Okay, so let's go step by step this project. So this project, you install the SageMaker at the first. After that, you are getting the data from the database. So the database is the IMDb database with the movie reviews. So the main target of this project is to make sentiment analysis and for the user to give a sentence, and the model is going to predict if the sentence that he gives, if the text that he gives is positive or negative, according to this movie reviews. Okay, so officially you're going to give a review, a movie review, and the app is going to say, is going to predict and say to you, give to you the result if it is positive or negative. But in general, it makes a sentiment analysis, so you're going to give whatever sentence you want, and the role of the model is to find if this word has a positive meaning or a negative meaning. Okay. So according to this movie database, you're gonna get the content of it, and of course the data for the training and the testing. Here you have this function, read IMDb data, which reads the data, of course, and it gives back the data and the labels. Okay, so here this directory here, it has training and testing data, and after that it has positive and negative. So you are going inside the training and the testing files, and after that inside the positive and the negative files, and you're getting all of them with this join. And after that, you have this data type, and sentiment, and you append the files one after the other. Okay, and after that, you are going to the labels, and you are doing the same thing for the labels. Okay, and after that, you are implement this read IMDb data, and you print out the how many data you have found for the training, for the positive, and for the training the negative, and so on for testing the positive and for testing the negative. Okay, so the next step is to prepare the IMDb data. So you have this data, you retrieve this data out of this database, out of this location, let's say, and you are preparing the data. So here you have positive training data, positive, negative. You concatenate all of this in order to have in general training data. And of course, again, testing data and labels for the training and labels for the testing. Okay, so you concatenate positive and negative reviews to make your data. And after that, you shuffle them. And at the end, this function returns the data for the training, the testing, and the labels for the training and the testing. And after that, you print out again the length of the training and the testing data. Okay, so here you print out, of course, the 100th element of the training and the 100th element of the training label to see what's happening inside the reviews. And after that, you have this review to words. So here is the first function in order to make a pre-processing of the data, in order to make them more helpful, more usable for the sentiment analysis. So here you have this review to words function, which returns the words, the actual words. So you give reviews and you get words out of it, in order to make the words usable for the model. Okay, so here you have the NLTK package, which is about the natural language processing projects. You download the stop words here. So there are some words that are not contributing to the sentiment analysis, like the, and so on. These very simple words that they don't have very specific meaning. And you download this. You also use the stemmer in order to cut off the end of the word because it is not very useful inside the sentiment analysis. You just keep the root of the word, which is more specific again. So here with a beautiful soup function, you remove the HTML with the parser, the HTML tags, and so on. Here, all the alphanumeric characters are going to be in lowercase. And here you split the whole sentence, the whole reviews to words in order to get the words and make your vocabulary for the training of the model. And after that, you take from the stop words the English stop words, here like that. And if not in stop words, then you're gonna keep the word. Otherwise, you throw them out of the words. Okay, you don't include them to the words actually. And after that, you have the stemmer in order to stem the word. At the end, you have to print this the 100th training data point, the actual review, in order to see the result, what's remaining out of this review. Okay, and this is a question here. We have mentioned that review to words method removes HTML formatting and allows tokenize the words. What else, if anything, does this method? So you have to describe here in your own words what's happening here. Okay, this is the first thing that you have to do. So after that, you have another here function, the preprocessed data. So this preprocessed data is getting the data and returns again the words training, the words testing, the labels training, the labels testing. And actually what it has to do is to use store cache files, to use some cache files in order to store the data, and for the data in order to be available, in order to spend much time and computation capacity in order to get the data. So this preprocessed data is taking again this data from the previous steps, and also you got this cache file preprocessed data.pkl, and here if you have a cache file already, so you give this preprocessed data. If the data there, so you just load this file where the data is, and you have the data inside this cache data. Otherwise, you take the data from the beginning, you are applying the review to words in order to make words out of the reviews. You got here the words, and you make this, you make a dictionary for your data, because the data is inside the dictionary, and with this 4 arguments. And here you open a file, and you add the file to this, you add this data to a file inside this location, okay, with a dump. And at the end, you get from this cache the data, okay. So if the cache exists, then you take the data out of it. If it does not exist, you make it and you store the data in order to have them available. Okay, let's go further. Transform the data. So here you create a word dictionary. So you have at the beginning the reviews, you take them, you concatenate them in order to make your data. You make words out of the reviews. So you take all the words out of the reviews and you store them in a cache, in a available, always available location. And after that, with these words, you have to make your own vocabulary. So this vocabulary, you have to make it useful for the sentiment analysis. Okay, so how are you gonna make it? This is like, this dictionary is like a bag of words. So this is the approach to make a bag of words. So you have a whole, you have a dictionary which has words, has the keys, and has values, has the frequencies. So all of the words are not as valuable. All of the words are not equally valuable. So you are just finding the most frequent words in order to see if it is valuable. And if the word is not very frequent, then it gives a lot of information. So the most seldom words are more valuable for the information that they give, because they give a very specific information that is not given always. So the most frequent words, we are use them a lot, and they don't have a very specific meaning. So this is two things about the natural language. And we're going to build a dictionary, a bag of words, in order to find the frequencies, and we take some insights out of it. Okay, so this is the main role of the build dict function. The vocab size has 5,000 words. So I think the whole English language has around 300,000 words. So it's a very big dictionary. And you give here the data and here the vocab size, construct and return a dictionary mapping. It's for the most frequently appearing word to a unique integer. So you have to do here, if you give here the build dict, here you get the word dict, so the vocabulary. And what you have here is to have the data, and you get the frequency out of it. You have the words in the data and get the frequency out of them. So how frequent these words is in the whole data set, okay, of the reviews. So here you have the word count, which is a dictionary, and you have to build a dictionary which has these two things, words and frequencies, for all kind of the reviews. From all the reviews, you are building this dictionary. Okay, so sort the words found in data. So the assorted words is the most frequent appearing. So the first word is the most frequent, and the last one is the least frequent. And here is the sorted words that you have to find from the reviews and from the data, and the data have the reviews, and so on. The reviews have the words. And here you have, this is the result, the word dictionary, which is the dictionary that you have built. And after that, here, this function has to keep the first two elements for the most, for the infrequent elements, and one for the elements that they are not word, okay, not word and infrequent. So we want to not have 5,000 words from the first dictionary, but we have 4,998, and after that we just push two positions to the end, all the words in the vocabulary, and you keep the first and the second place for the no word and the labels. So this is a detail. What you have to do is to make this dictionary which associates words and frequencies. And after that, your answer here is to use the space to determine the 5 most frequently appearing words. So you have to print out the first 5 words of this vocabulary. So the vocabulary will have the most frequent words as again in the beginning. So you have to print out the first 5. Okay. And after that, you have the vocabulary. You have to save this vocabulary, this word dict, to a position in the data directory. So you take this, it takes this word dict file, and it saved it here with dump. Okay. After that, you transform the reviews. So what's happening here is you have here another function, the convert and pad function, and another function converting pad data. So this function has the result and the length at the beginning in the data, and calls the convert and pad function. According to the pad, you will have to pad the data in order to have 500. So you have reviews until 500 words and not bigger, because they are not reasonable. And you give here the vocabulary, and here is the data of the review. Here you give again the sentence. So from all the data, you just take a sentence, which is the actual review. You give here the vocabulary and the pad, and it takes it here. So you have to find for every word an encodement. Okay, a number that will encode the word. Okay, so here no word multiplied with a pad. So you have the sentence until the pad limit, which is 500, and here you have to find the right word according to this index of the word. So you take the word and you are making an index out of it in order to put them inside the working sentence again. Or if this does not include it inside the vocabulary, then it is an infrequent word. So here you are returning back the sentence as it is the sentence, which is a review with numbers which are corresponding the words, and here the length of the sentence, and so on. So here you just giving back the converted review, and here the length, and you append the review and you append the length again. Okay, and you're returning this result and the length of the reviews. Okay, and after that, you are implement this converted part data to the training data and the testing data, and it gives back the training data in the form of the numbers. So if the numbers are low numbers, then we know that from our vocabulary that there are very frequent words that are behind these numbers. If the numbers are high, then we know that these words are infrequent, so they have a rich meaning. And of course, you're giving here the length of the review. So if the review is big or not. Okay, so if it has a lot of zeros, no word, for the review would be very small, quite short. Okay, and use the cell to examine to make sure everything is working as intended. So you have to call again here a review in order to see how the work is done. Okay, so the most important is that to see how the work is done, and of course to answer the question. So in the cells above, we use pre-processed data, convert data in order to process the training. So what's your opinion, let's say, what is going on with these functions? Okay, you write it down right here. Okay. The third step is to upload the data to the S3. So here you concatenate, the data are concatenated again from the trainings and the training labels and the training data and their length. And here are uploaded to this to the default bucket. Okay. So, and according to their role. So here we have the input data that are going to be used inside the training. And here's the fourth step, which the building and training of the PyTorch model. So you have the model artifact, the training code, and the first code. We're going to see them after that. So here you have some files in this directory, which is the directory of the project. So you're going to use them. You're going to change them a bit. So you have this train directory, which has model PI, requirements, txt, train PI. So there are three files. The first one has the model that is going to be trained. The second one is the requirements of the other two files. And then the last one, the train.py, is the file that is going to train the model that's inside here. Okay, so this model is going to be printed out here. You're going to see the model as it is. So it is an LSTM model. As you can see here, this is the LSTM classifier with a sigmoid after that and a linear layer. And here is the forward, what's going on here, embeddings, LSTM, and after that, a dense layer and the out. Okay, and let's go back. So here we have seen this here, and after that, as you can see here, we read the CSV files from the train.csv, which we have which is the sample, and we make this data, which is the sample of our S3 bucket. We make this data tensors here, and at the end we are making the data loaders. We make the tensor dataset here, and here the data loader. So the data loader, they have already data in order to feed the network and to train it. And after that, you train the model here. So here, for every epoch, you have the loss, you have the training loader, and here you have the batches. You are using GPUs, and here you have to make your own code in order to train the data. So this, the training code for the PyTorch model, I have made another session how to train a model inside the PyTorch with the PyTorch framework. If you want, you can see that and find more or less the solution there. Okay, and after that, if you train the model, you are just going here in order to to implement the function and call the model to implement the Atom classifier, and at the end to find the BC loss, and here you are calling the training method in order to train the model. Okay, here the model is trained. This is the first solution, to write the code on the notebook in order to have a first testing of the code to see if the code is running, and if it to test it with a few epochs, like 5 epochs here. Okay, but after that you have to make the real training. So how to train it? We apply here the loose coupling architecture. Okay, this means that you are gonna call the files here. You can open the files here and call the functions out of them, which are here. We call the model from here and the train.py. So how are you doing that? You import PyTorch here and the PyTorch from the SageMaker class, and the PyTorch here makes a model, which the entry point is the train.py, which is the training file. There is a Python script in order to train the file. Here is the data source, and here is the instance. Okay, for 10 epochs this time. So this is the real training, and the hidden dimension. So we fit it here. What we have in these files, again, inside the train.py, we have a main here, which is the starting point of this file. So here we parse these arguments according to the calling. So here we have the basic dimension, for example. We have the vocab sites. We give them inside the notebook, as we have seen, and here the colors, cost, and so on. So what it's gonna do here is sets up the CUDA, the GPU, and after that it takes the train loader, and here you have the LSTM classifier, which is taken from the other file here. As you can see, model import classifier, which is this file here. Okay. And here you open this verdict in order to use the dictionary that we have made in the previous step. We open it, we apply it to the neural network. We set up the atom again, the BC loss again, as it was in the notebook, and here we save it this model inside checkpoint. Okay, we save this model info here, so the hidden dimension, the vocab site, and so on. And after that, we save here to another direction the status of the model. So another checkpoint with the status of the model, the weights of the model, in order to save the model. And at the end here, we save again the verdict. Okay. So here there are also other functions. So the train function is here, which is called inside this train function is defined here. Okay. And as you can see here, you have to make the training again. So the training that took place inside the notebook took place also here in order to train it inside this file, and this file is going to be called from the functionality from the PyTorch model inside the notebook. And this is how you have the loose coupling. So the model is here, which is called from the training, and the training is called from the notebook, and you have more usable code. So you may use this model inside other notebooks, and you may use this training code here inside other notebooks too. So you have to copy the file, the code that it had been used in the previous step, and it works. You have seen that it works here in order to be used from this file right now. And here, as you can see, this the get train data loader. So you also call this data loader here in order to have the data loaders again, as there was in the notebook, and so on. Okay, so we have here also a model FN. We're going to see afterwards what's going on with this. So let's go back to the notebook. So the notebook plays the role of the workflow, and is calling the codes from the other files and making models and vocabularies and so on. So the fifth step is to testing the model. So deploy the model for the testing. So here, what you have to do is to deploy the model. Okay. So how to deploy a model in the SageMaker? I have shown in the previous session again. So watch the session in order to get the solution. Okay. So use this model to testing. So you got the model here. The model, this is the one detail you have to save it in the predictor variable, because it's gonna be used here. And after that, you concatenate the data frames for the length and the data. And here you are applying this predict function, which gives the predictions. Okay, so here we get the data, we split the data according to the words. We are making an NP array, and here the split array, you give his array here, and with the predict function of the predictor of the deployed model, we are getting the predictions, and we are appending the predictions. Okay, so here we got the predictions out of this predict function, and we can make the predictions out of this predict function. We give here the test x values, and here you get the predictions, the actual predictions. So you have the predictions, all the predictions for the reviews inside this test x dataset, and you round the amount of it. Okay, so for each prediction, you round it, because if it is 0.9, it's going to be 1 in order to be positive review. If it is 0.1, it's going to be 0, and so on. So let's go. So this is the binary classification, let's say, and from the accuracy score, we get this this function accuracy score. We have these predictions. We have also our test Y data from the IMDb the dataset that they are already pre-processed in order to be a good comparing with the predictions, and you see the accuracy score here. Okay. So here, how does this model compare to the XGBoost? So you have already the LSTM model. You have to compare it with the XGBoost model from the other notebooks. So here you got this notebook, which is only one file. You download it, you are running inside the AWS or inside an AWS account in general, and you are seeing here the performance of the XGBoost, and you are seeing here, you can compare it here with the performance of the LSTM classifier. Okay, and the result you're going to answer here, what's the comparison between the XGBoost and the LSTM models. Okay, more testing here. You're going to test this time this test review, which is a string, in order to use it afterwards in the files. So here, what you have to do, convert test review into a form usable for the model. So here, what you have to do is to pre-process the data again with the review to words function, which is defined above, and the converted path function, and you get here the length and the actual review out of it. So you pre-process the review and give the length and the review with the processed words. Okay, again, you have to do this here. Okay, to implement these two functions and to get the length and the converted words. And after that, this test data, which is from here and now it is processed, you give it here. Okay, you give here this string, which is pre-processed, which is actual afterwards some words, stemmed words, and so on, and the length of it here, and you get the prediction here. If it is close to 1, then it is positive. Okay, and after that, of course, you don't need any more the endpoint. You have to delete it. Okay, so you have deployed the model. You have seen how does it the performance of it with the labels of the with testing data of the IMDb review. And after that, you give your own here review. You give here, you take also this prediction, and you don't need any more this deployment. You delete the endpoint because it costs. Okay, and after that, the sixth step is to use again some other files. Okay, in order to make loosely coupling here again architecture. So you have here these files. So here you have requirements, which are modules, utils. So inside the utils, you take the review to words and you write it down here in the convert and path in order to down them here in order to be used from the other files here. And here we have again the model. So the model here is the same as the previous. This time it gives the length and the it gives out also the length, and it tells here the out.squeeze. It gives out here the prediction actually according to the length of it, and here you have the prediction. Okay, so the prediction here you have the model FN. So this model is going to be used from the PyTorch framework. Here you got this model FN, so it makes this. It takes the checkpoint. It takes also. It makes the device to CUDA. It takes also the model. So here you get the model info as the previous model it was. So there are some infos around some parameters. Okay, that I have commented. So you take here the model. So the weights of the model is here, and you take also the word dict. Okay. And after that, you have to take here the other function that you have to input the data. So it takes the text data and it decode them to UTF-8. And after that, you just serialize them in order to have the right output. And this is here the predict. So here the predict, you are taking the device, and here is to do. Okay. So the code that you have written before to test the string and to convert them back the data and to review to work. So you give it here. It's the same code here. You have tested. It works. Right now you copy it and you paste it here in order to have it inside the file, and it's going to be called from here. Okay. So here this is going to be stacked, the results and the shape. And after that also you have to compute the result of applying the model. Okay, with inside the result, if contains 0 or 1. Okay, and you give it back. Okay, so you pre-process here the data, and after that you take the prediction. You have to write the code, the PyTorch code, in order to take the prediction. Okay. So after that, we are going back to the notebook. So this was the 4 files that are here, what they are doing. So here you it is print out the predict PI, which has the prediction code. Here, this is the PyTorch model, which is again imported in order to use the predict.py file here, and the functions that are inside it, inside the serve directory. And here you have the instance type and so on. So you deploy the model here, which model is this PyTorch, and it's called from the predict.py file, which calls the model.py file, which has the model inside it. Okay, and uses converted path from the utils.py. So this is a architecture that is logic capping, so you can reuse again in other projects the model, the predicts file, and of course the utils, because you're doing the same things in many projects. Okay, and here is a string predictor in order to take the string and gives the text plain and gives the prediction out of it. Okay, so at the end you have these test reviews. So from this data directory, there is a function that gives back the result of the prediction according to the ground truth. Okay, this is the ground here. So here you have this directory, you have some positive and negative reviews here, and you give here the test. You join here the path, this test path according to the positive and the negative, and you take at the beginning some positive reviews. Okay, here open F, which is the positive. Or the first one is it runs the positive files, the positive reviews. Here you open the review. If it is pause, append 1, or otherwise 0, and after that you append the actual prediction here. Okay, and after that for the negative, the same one. You append the actual prediction, and here it saves if it is a 0 or a 1 according to the negative or the positive. And at the end, if the files are 500 and so on, so you have here this limit, they are 250, and you are going to find 250 positive reviews and 250 negative reviews. You're going back here in order to see the results and according to the ground truth. Okay, and you give them back this. So you according to you implement these test reviews, and you take this ground and results. So here from this ground and results, you are going to give them both to the accuracy score again, and you see if the actual prediction can be is the same as the ground truth. Okay, and you get here the accuracy score, because from the same reviews you know already if it is positive or negative from the IMDb dataset, which is here. Okay, so let's go. After that, you have this predictor. You give here the test review, which was the first one, the string, and you get after that in order to see how does it works for this review, more testing here, and you get here the result if it is 1 or 0. So you have to take 1 because it's a positive review. So you have here a deployment of your model, a decoupled deployment, loosely coupled deployment from these files here, and your application is let's say ready. But how to make an application? because you want to not to open a notebook, you want to open an application and to use the actual application and to take reviews from there. So you have a user interface. Okay, so you use the model for the web app. So here's the architecture that you may use. That is going to be used from the project. So you have the application, you have here the API, okay, which is the application interface. Here this triggers a lambda, which can invoke the model. Okay, you communicate with the model and take the predictions. Okay, this is the whole thing what you can do with AWS and of course other cloud engines. Okay, so you can do that with API gateway. You can do that with AWS Lambda and to call the model that is inside here. Okay, so you call of course the deployment inside the notebook, and the notebook has already the model from here, the prediction, which is the model from here. Okay, so here you set up a Lambda. Okay, I have shown about the Lambda in the previous session for the AWS Lambda. So you create the Lambda, you put here this kind of code. So here you invoke endpoint, which is the endpoint from the previous deployment that you have always. You give here the endpoint here, content type text plain, and here you give the body. So this is the body. You are writing your review inside the web app. The API takes the review, and this is the Lambda function takes the body of the review and sends it to the deployment. Okay, to the endpoint here. Okay, which has a deployment. So this is with the two words. This, and it returns the status code 200 and also the content type and the result. Okay, so the result has to be positive or negative from the model. Okay. So this is the Lambda handler. You got here always the endpoint. You get here the endpoint from the deployment, which you have to give it here. Okay, inside the notebook, you give it here inside the Lambda function, inside the AWS Lambda service. And you setting up here the API gateway. So you are going to the API gateway service of the AWS, you create an API, you set up the Lambda proxy, okay, and you are making you're making an action. You're making a Lambda, you save it, and so on. You're going to make it a post method, because we are posting a method inside it. We are posting the review inside it. And after that, deploying our web app. So you have an index file inside the project. So here is the third file. Let's see that, which has the index file. So here we download it. As you can see here, this is here a public URL, which is the URL that you take from the API at the end. And here's the submit form, a button. Okay, so you are writing down in the submit form your review. You are pushing the button, and then this is API is called in order to this API is called in order to give the body of this to the Lambda. Okay, so this is what we have to download it. So you invoke this URL, you download the web app here, and at the end, you download, because of security reasons, you download this index file. You are running it. This is opened inside your browser. You're writing the review. This communicates with the API gateway. The API gateway has the Lambda proxy, which with the code that triggers invokes the model, and the data are sending through this Lambda to the model. Okay, and after that, this is a question, the last question that you have to answer. So inside this, you may take a screenshot of your app, and you put this screenshot inside the files, inside the website file and so, and this displays this here it displays the image file, this image file. Okay, and you put here the answer, what was the predicted sentiment of your example, and so on. So with two words at the end, of course, you have to delete the endpoint. in order to not to cost you anymore because you have taken the prediction out of it. So you have made your app with this API gateways with the Lambda and so on. Inside it calls the notebook. The notebook goes here to the serve, and you have here the predict function, which is deployed inside from the notebook, and the predict function calls this model and so on. So you have an application which is a whole project for a sentiment analysis in the whole machine learning project, which can be in the production line because it runs continuously in the AWS services. This says with 5,000 words, a train model with 500 words, which are a lot of words. And there is a very good vocabulary in order to make further sentiment analysis for all kinds of sentences. So it is a real project in order for you to make predictions for your texts, which can run continuously, and you can also have it as an application for yourself or your company. Okay, so this was the whole thing. I'm stopping sharing here. I hope that you like this project. If you have any questions, I'm very open for the chatting. Thank you very much for watching, and bye, and see you in the next session.